All right, welcome back. We are Game 2014 in the fall 2020 semester at George Brown, and it's week 4, part 2 of our broadcast. We were just, before the break, what we did was we were up on Unity, and what we did was we set up a test button, and we ran the test button. What it would do is I can press the test button, and it would change the scene name. Why did I do that? Why? Because I wanted to see, can we affect the scene label, and I wanted to show you how to, modify labels in the scene. You may not know how to do that at this point, and I wanted to make sure that you knew how to do that. So now that we know how we can modify labels in the scene, we don't need the test button anymore. The test button was just there just to see, can we do it? Okay, so I'm going to go to the test button, and I'm going to just disable it. So if you go to the check mark next to any game object, you can disable them, and then they won't appear in the scene anymore. Even though they're in your hierarchy, they won't do anything. They won't make any effect in your scene whatsoever. None of the scripts attached to them will function. They're just not, almost like they're not instantiated. That's what they're not. Okay, so what do I want to do here? I want, in the game controller this time, in the game controller script, instead of doing a debug log, I want to change the scene label. So again, the way to do that would be, if I go here, and if I go to public, I want to have a TM Pro text object. We're going to call it the scene label, just like we did in my test button. And I want to take the scene label, and I want to say that instead of a debug log, scene label.text is equal to portrait. And then I'm going to say scene label.text is equal to whatever. Right, so this will be landscape, and this will be landscape as well, and unknown, because we won't see these debugs. That's what I'm saying. The reason why I'm doing this is because we won't see the debug log at all in any way, as an example, inside of our VM, because we don't see debug logs. We can only see something that's in the scene. So that's why I'm using the scene object, which is the scene label, just to facilitate us knowing what orientation we're in. That's what this does. Are you with me? So all I've done is I've done the same thing. I've made a scene label. I've typed TMP text, and I've modified my gamecontroller.cs to have scene label.text change according to the device orientation. Check mark for yes, you're with me. X if you don't know what I'm doing. Awesome. These are like little baby steps, guys. Thank you for the feedback. They're little baby steps because, I want to show how this can work. Okay, so first we want to detect orientation change. If we can't detect it, then we can't do anything about it. So here I'm proving we can detect orientation change. We couldn't detect orientation change here. Here we know it's not working. So if I run this thing, we should see something like unknown, right, when it starts. And, oh yeah, one thing to note is we didn't configure my scene label in my game controller. To do that, we have to drag and drop this into my game controller script, onto my game controller script, which is on my game controller object. Then if I press play, we shouldn't see this error anymore, and it says unknown. Unknown means that we're in an unknown orientation. Why? Because our editor cannot detect the orientation of the device. All right. But what does it look like on the actual VM? Let's push it there. So I'm going to say File, Build, and Run. And we're going to go here, and let's watch and see what it detects. Now, we're hoping that it's going to say Portrait. If it doesn't say Portrait, that would be bad. That means we can't somehow detect the orientation. And if we can't detect orientation, then, my friends, we're going to have to figure something else out. Now, I'm positive this will work, but this is part of the testing process. Can we detect orientation on the device, right? So now it's going to push across. So you should be able to see the same thing as me in a few minutes. Again, if you're watching the video and you don't want to wait for this to push over to the device, please fast forward. Okay, so we're at the Gradle part right now, and we're in the start scene in a second. If I click start, then, hey, portrait. So it detects portrait. How about if I switch it to landscape? Hey, landscape left. But this thing does not detect landscape right. It doesn't do that. It only moves left, or portrait in this case, right? And that's okay. I'm fine with just those two. I know that it works on one side. It's going to work for the other side. I'm pretty good with that. And again, we want to test on a real machine, a real device, if we had a chance to anyway. This is good. So now that was our next test. We know we can detect orientation, which means now in my game controller, let's go back to my game controller.script. We don't want to modify the scene label. That scene label was just there for us to modify, just in case, as an example, we wanted to change this up. Actually, let me undo that change. I'm just going to comment this out, just in case we need to do that again. I'm going to comment this out, and I'm going to comment all these out too. This is just our testing. We can remove them later on when we do optimization in another day. But for now, they're just there, just in case we need to detect an orientation change, or we want to confirm that it's in a special spot. We can do it. Okay, so what's next? So now that we know that these little cases work, if there's an orientation change, we want to modify the position of the objects that are in the scene to adapt to the new orientation. So going back, what I mean is this is okay, but we should go to landscape. Let's go to landscape mode. And this is specifically landscape left, right? So in landscape mode then, there's a couple things I want. I want my lives label, which is right now, if I look at the rect transform, one thing to note about UI elements, canvas elements, instead of having a regular transform component, they have a rect transform. And this is because they're sitting inside of a canvas. And they're relative to the canvas. That's what the transform is. Okay? And it also provides other issues. So where we are right now is we're sitting at a position of 248 and minus 200. Well, where it should be is we want to get out of this safe area when we're landscape left. We should be, actually what we should do is capture this first. 248 and minus 200 for the lives label. And we should also capture minus 353 and minus 200 for the score label. We should capture those two things. But in order for us to capture those things and make sure that that happens in portrait orientation, right? So if I go back to portrait, these are the original values. We want to capture these values when back in portrait. I need references to lives label and score label in order for me to control them. So going back to my script then, inside of my my game controller script, I want to create two references, not scene label this time, but rather lives label and score label. So public TMP text lives label and public TMP text score label. So again, the public makes it so that it exposes any variable that you mark as public to the editor. Now there's other ways of doing this as well. You can use serialization, but for now this is what it's okay for us. Okay, again, basic. So now what I want to do is I want to change both the lives label position and the score label position in portrait orientation mode. Let's do that first. So in portrait orientation mode, just underneath that comment, I'm going to say lives label dot rect transform dot position. This is what you would think it is. This is actually wrong. Is equal to a new vector2 object, and what we want is to capture those values. Okay, so what is the value for the position of the lives label in regular mode? So again, regular mode, if I look at the lives label and I look at the X and Y positions, it's 248 and minus 200. So that goes here. 248.0f and minus 200.0f. F for float. All right, cool. Let's copy this and paste it there and change this to score label. Score label. There we go. Score label.rect transform.position. This is wrong. I can tell you it's wrong. And then what would be the values? The values of the score label, if you go to the score label, are minus 353 and minus 200. Okay. minus 353, and minus 200. Okay, what? That's crazy. Like, those are weird values, but it makes sense for where they're positioned, right? They're positioned right at the edge here and right at the edge over here, and for our particular reference phone, it's okay, right? Minus 353 and 200 as an example. And that's where these two things are. So we've captured the positions in portrait mode. Okay, let us make sure that our game controller has references to the lives label and score label. So lives label goes here, score label goes there. Okay, so let's, again, so game controller has a game controller script. We've exposed lives label and score label as two Text Mesh Pro text objects. We've just pulled them in from the canvas, lives label and scores label. We've done that. And now we have references to those two objects in the canvas. What we're going to do is, when it's portrait orientation, what we want is for it to revert back to these this basic position, this default position, if you will. Okay, but what about if it's landscape left? Let's grab these values and we'll put them back underneath here. So landscape left, let's go there and do that. So let's rotate back into landscape left mode. Here's landscape left. And what I want is, I want to put this lives label in position. Okay, so where should it go? So I'm going to grab the lives label. I'm going to use the move tool and I'm going to move it so on the example here on the bottom, I'm going to see where it belongs. So kind of up to there. Right? That looks about right. And the score label, let's do the same thing. So I'm going to grab the score label and I'm just going to move that up. So one thing to note is the position of the score label is at minus 83 on the Y and minus 353 on the X. So the X position didn't really change. But on the lives label, both values changed because I moved it from here all the way in there. So the new values are 370 and minus 83. And on the score label, the new value is minus 353 and minus 83. Now, minus 83 might be a little bit too close to comfort, but hey, let's see what that looks like when we actually go in and try it out. So again, let's skip back to the code. So in the code then, we want to change these values to the new values. So on the right, this is minus 353 and minus 83, right? That's this one. And the lives label on the left is 370 and minus 83. Okay, that's the new value for landscape left. Let's copy these and put them inside device orientation right. And now we have new values for these. Device orientation right, we're just going to rotate the device twice this way. And now our safe area is here. A lives value on the left. We're going to pull this back to the left. And we're going to pull this to the right, to the left as well. So I'm going to grab this one and move it over so that it kind of hugs the left. Approximately. All right, so what are these values? So lives label, let's take a look at that. It's 248 minus 83. That's aligned with what we originally had. So 248 minus 83. And on the right, for my score, it looks like something like 498. Let's make it minus 500, just to make it even. Minus 500 and minus 83. We can change these values if we want to later and make them all even values. For now, I'm just taking what I'm saying. Cool. So I've got positions, and now we can reset everything back to the way it was. So let's go back to portrait mode. And I will undo, undo, undo. So let's do that. So undo, undo, right? until you see them there. And I think it's got to be there. And those are the original positions. Cool. Okay, but remember we can't test them in any way. There's no way to test them, right? So how do I make it so that I move these things where I want to with a button? So I can't set the orientation. I can't say it's equal to. I can't do that, right? Because it's going to flip back on me because it only works once if I set the orientation. But I can move these things where the orientation left is. So again, let's bring back that test button for testing. So I'm going to say, hey, test button, let's bring you back. Here's my test button. But this time inside of my script, inside my test button script, instead of just making it say test, we don't want that. Instead, I want to grab the game controller stuff that I just had for orientation left, for my landscape left orientation. Let's grab these two things. I don't have references to lives label and score label. I'm going to have to make them there too. That's okay. Again, this is just for testing because I'm going to simulate what it's like to have my lives label and score label work. I don't need a scenes label, but I do need a lives label, and I do need a score label reference in my test button. Notice that that's why I have a test button, so I can make sure that it works like this. Score label. So I can make it happen. I can move these things around when I want to. Yeah. Now I have to make references to these here. Right? And I'm going to go to my test button, and on the bottom here I have label, lives label and score label. I'm just going to pull those in. Again, I'm going to press the test button and they're going to move in position when I need them to move. And this is going to simulate what it would be like if it detected the orientation change, which it cannot. Let's run this thing and see if it works. So, running. I am in regular mode. I want to move to a orientation change. And when I click this test button, it's going to fail. Why? I've done this before. And it doesn't work exactly how we want it to work. And I'll explain why it doesn't do that in a second. I'm just going to show you what it actually does with them. Test. Oh man, what the heck? How could I move my score label and my lives label way off screen down here? Does anyone know why? Well, the person I would think knows why is Russ. Russ should know why.
Is it based off origin 00 bottom left?
It is based off, I use the transform, right? I use rect transform. But the thing is, rect transform, I use position. Position is relative to what? There's two properties. There's position, there's something else. Yes. So what happens is, look what it did with my transforms. If I look at my score label, right, it's like minus 3,393 and minus 1,523 relative to my anchor points, right? Relative to my anchor points, it's like way down here. Why? Because I use position, and position refers to my global position, right? Not my local position. But there's actually, it's not even local position you want, it's actually something called anchored position. Let me show you that. So instead of under lives label rect transform position in my test button, let's change this to anchored position. Anchored position. Anchored position says whatever relative to the anchor is, that's what I want to do, as opposed to position. And again, guys, don't get mad at Unity for this. They've created these properties so that they solve problems, right? Someone somewhere wanted a global position, and they were able to produce it with a position value as opposed to anchored position if you're going to move things around the canvas. Okay? Because normally they don't expect you to do that. All right, so cool. So anchored position is the way to go. So that means I have to, that's my test. Let's see if it works, first of all. So going back, and I want to run it. And if I click on test, then I want this to go up here. Hey, it looks good, right? It looks much better than before. It's where it should be. It's not too low. it's adjusting for the size of the area. This is good. So now that I know that that's working, that's why I need my test button, guys. You're like, wait, why test button? Who cares about that? Yeah, you're right. If I had everything working from an orientation perspective, who the heck would need it? But I need it now. So going back to this then, let's go back to landscape orientation just for a sec. Here's my landscape orientation. And let's get rid of that test button. I don't need it right now. So test button, I'm going to uncheck it so it's not going to be in the scene anymore. And what I want instead is inside of my game controller script. I want to change that instead of position, it's got to be anchored position. Now let's change it for all of them. I'm just going to copy paste. Again, you can search replace or find replace. I'm not going to do anything for device orientation unknown right now, but I could. I could put them in the middle or do something weird. But for now, let's leave it the way it is. All right, so those are the ones I care about. I could leave these ones out, and when we optimize in a week or so, we do some device optimization, then I will remove some of the stuff. I'll remove things like starts and updates when I don't need them, and a bunch of other stuff. But for now, this should be okay. So when I move into portrait, I'm going to have the original position. When I go to landscape, it goes to that special position for landscape. And if I could simulate landscape right, then it would go into the right position as well. Cool. Okay, let's push it to the simulator now. So up here, we've done it. We've coded it. Now we have to test in the simulator. And I'm going to do that by going back to portrait orientation. I don't have to, but I'm going to. And I'm going to go File, Save, File, Build, and Run. And let's watch it go to Genymotion again. So again, in your mind, I want you to understand my thinking. I couldn't simulate the orientation change, so I needed somehow to test my values out somehow. And we saw that, you know what, making my labels move to position was actually wrong. I couldn't test it. And this is going to be a challenge for us throughout the development. There is no way to detect orientation change that I can see or that I know about, right? I mean, the device simulator is really cool. It turns, but it doesn't trigger the orientation change event, right? So we want to trigger it ourselves. Okay, so here is this, and we should see a normal scene in the start scene. And when I go to the play scene, we're good. Up here, it looks like it's okay. And if I change it, then we should see it change up to here, and it looks pretty good. Why? Because there's a bit of a gutter on the left where I would have my devices, and it's much higher up. Notice where it is on the right. So much better, much nicer position. I could also rejig my center position if I'd like. If I want to move this further up or whatever, I can make some other changes. If I had a background, or if I wanted enemies to come in from the left somehow or something like that, I could adjust their position by providing some kind of offset based on the orientation values. Okay, so that's why we do this kind of thing in the first place. So now we have some sort of orientation detection, and then some sort of adjustment to our layout based on the device orientation detection. Hurrah! That is your lab. Okay? So now let us do a couple more things. Let's push this to GitHub, this first version, and then test it with another device. Okay, so let's stop this. And what I want to do when I push it to GitHub is I want to file, save. I'm going to do file, save project. I want to close down Unity, right, as an example. I'm also going to close Genymotion down, right, and Visual Studio, right? And the reason for this is because I want to make sure, hey, by the way, let's see if I can post this thing now. It should be good. We should be in good time for this kind of thing. Go. Hey, it worked. Part 2 is actually live now. And we'll post this on Blackboard for you guys, for who need it. Okay, there we go. Yeah, so I want to go up on GitHub, and I need a new repo. Let's go new. And I'm going to say it's going to be public. Game 2014 in the fall 2020 semester, and it's lab 2B. So I've got a repo up there. That's empty right here. And then what I want is I want to go into my command prompt, pull that up. I'm using command prompt. You can use whatever you like to put it up on GitHub. It's up to you. I find this is comfortable for me. So cd space, and then I'm going to drag and drop my lab2 folder onto there, and then press enter. And then from there, what I want to do is I want to do all my commands. So git init, git add dot, git commit -m, initial commit. This is kind of my initial feature set. Okay? And then what I want to do is I want to go back to this, copy the last, actually what we should be doing now is copying the last 3 lines of code. This is a new thing, by the way. Branch master was never there, and they've added this in lately. What it does, it makes branch master the default branch for pushing. So if I grab all these 3 things, it's a new change actually in GitHub. And if I go right and then I press enter, it'll push everything up to the master branch. Yay! Awesome. And when we look online, you have lab2b as an example. And there it is. You would have to put your lab2b up or 2, and when you submit, all I'm looking for is the link to GitHub. Please don't give my link. It's got to be your work that I'm looking at, not mine. All right, so what we want to do now, we've done our lab, but I want to test to see that everything else is going well with another device, right? I want to confirm that things are good. So I'm going to pull up Unity Hub. I'm going to go back into our lab here. And good thing is hopefully it won't start off any slower than last time. This is pretty good. So we can get back into Unity pretty quick. Now I made it public, not private. You can make it public too. It's fine. All right, so this is good. I want to pull up Genymotion now, and let's see what kind of devices we have available to us. Right now I have configured an S7 and an S9, but let's make a device that's physically smaller than what we have. We have to be careful about the V7, ARM V7 thing, because we still have to do that too. So again, I'm going to click plus. I'm going to look at about different device options here, and you can see that there are, we can go with a Google Pixel phone. You know, there's quite a few different options here that we have. But I want to go with something physically smaller, and I think the Pixel 4 would do it if we had such a thing available to us. Pixel 2, and it has to be the right level, which would be nice too. So let's just go Pixel. So let's just search and say Pixel. Looks like we have a Pixel 2, and the resolution is definitely smaller. But we have API level 26 and level 8, which is pretty good. We can also choose the API level. So I can choose, well, I only want level 9 or level 8. Let's do level 9, so it limits the phone. So it's the same level that we were at before. We could definitely choose other phones too. But I'm going to choose the Google Pixel 2, something smaller, right, than what we have, right? And let's click next. It's going to be predefined, and I'm not even going to change anything here. I'm just literally going to just install. So it's going to download and create the device with the new options. And I want to click start. It's going to boot the device. While it's booting, I know I need that fix, so I'm going to get it ahead of time. I go and grab that fix for my downloads. I have it here still. Probably should put it somewhere else. I have a messy download, but there it is. There's my ARM translation, option for Oreo or 8. Doesn't matter. It will work for 9 as well. So I can pull this all over from the ARM 8. If I pull this over here, it'll say, "Hey, it's detecting that it is flashable. Do you want to flash? Yes, do it." And then it'll flash this device. This actually looks wider. Although the resolution is different, right? It's going to restart the device. Let's do that. So we'll go back to Genymotion and restart the device. Start. Actually, it's just because I have to scale it. But you can see that, I mean, the resolution is way low. 1080 by 1920, where we're working with a resolution of 1440 by 2960. Pixel density is 420, so it's a totally different phone. And what I'm hoping is that this is going to work just the same when we push it over to this thing. So again, I'm going to just scale it down so we can see it a little bit easier for you. There we go. So scaling it here, different resolution, different phone. And this is the Google Pixel 2. Let's make sure it looks the same here on Unity. So I'm going to choose that. So I'm going to say Google Pixel 2. Smaller phone without a notch, right? Without a notch at the top. So we're going to have extra space up here. Okay. But this is what it's going to look like. Let us see if we can detect it. So again, I'm going to go to Build Settings, and I'm going to do Refresh, and I see my Google Pixel 2. Yay. Let's push it over. Build and run. This is asking me now, because it's a different device, to resave it on top of my APK, and I'm okay with that. But this means a longer build time slightly as it pushes it over to this new device. Again, it'd be nice if we had a smaller device to test with, right? That had much smaller, like let's say something like an iPhone. And in later iterations, I'm going to switch to my Mac on the back end and show you what this looks like when I run Unity on my Mac with Xcode, right? So you can see that it's going to work cross-platform. That's the idea behind this thing. Okay, it's building, and it should be pushing across, and hopefully you won't get a black screen. That would be bad. And we should be getting everything, and it says got it, full screen, and we're good. Right, so it works. Run. The start scene looks like it's okay. All right, let's click start, and yeah, now this is a problem. Take a look at this. So this is device detection. That's a different thing. So notice that our resolution is something we should also check for, not just you know, the orientation change, right? I mean, it's okay that the score and the lives are where they are because they accommodate a lot of phones this way. But for this phone, in this particular case, it doesn't look the best from a layout perspective. Okay, let's do the orientation change and see how that works. And it works okay, right? We look at, you know, what we have over here, except we have a bit of a gutter here. And, you know, I'm not sure, but I don't think the Google Pixel 2 has a gutter area at all. Like notice this one doesn't have a cutout, right? So the safe area is the entire screen that's available on the phone. So what happens in terms of that option? Because we have to make sure it works. But I'm happy to report that at least it did align, and we were able to see the majority of our user interface on screen. So are we done? Is the question. The answer is not yet, but we need to detect resolution values, right? What is the resolution incoming of this particular phone? Can we get it from our OS? Do we want to get the ratio? What is it that you think we need? And what would you do to solve this problem? Or would you solve it? Would you solve it at all? Is the question that I would ask you. So I want to get some thoughts.
It looks okay on my end. So what is the issue though with it?
You don't see the issue, Michael?
No. It
No?
looks okay on my screen.
It looks
Look
okay
at
on my
this
screen.
over here on the left.
Yeah, that's because we're.
Yeah, but that's because we're purposely pushing it
Right,
out
but I'm
that
saying
way,
from a
right?
layout perspective, this phone doesn't have a cutout, right? So from a layout perspective, it's not the best. And same thing goes when I go into portrait mode. Portrait mode, I got a big buffer up here, and I want to use the maximum amount of screen space I can, and I've got all of this up here, right? So I can probably push this up in portrait mode as well. So this is another issue, right? It's not just orientation checking now. It's screens. It's the resolution check, we have to make. What is the resolution? How much space do I have in the top? Do I have what's my safe area? You know, kind of stuff. Do I have a safe area that includes a cutout or not? And here we don't have a safe area. Safe area is the entire, you know, kind of, you know, size of the phone. So what do? Do we detect older phones? Do I do device detection? Or is there another way? And do we care is the answer, is the question I want to ask you, right? What is it? Do we care about this kind of thing? You know, we want to support a phone like this.
Make the anchor relative to
What was
the
that?
safe area?
Can you make the anchor?
Can you make the anchor for the safe area instead of the screen?
No, not that I've seen. We can adjust it. We can calculate the anchor based on what we want. We can move the anchor anywhere we like. That is definitely something we can do, right? But the problem is the anchor is something that would have to move based on if there's a safe area or not. And I don't think, I'm just going to look it up, I don't think there's a safe area detection with Unity. If I looked it up. So if I said like safe area detection Unity, I don't think so, right? Well, actually, let's see. It says screen safe area. On some displays, certain areas of the screen may not be visible to the user. This may cause, and it returns the safe area of the screen. Well, there you go. That's new. So rect 00, screen width, and screen height. That's awesome. All right, so screen.safe area. There's also other things we can look at the screen. I was going to look at other stuff anyway. It says auto rotate to landscape, right? And auto rotate to landscape, if I'm not wrong, that's a static Boolean, right? So allow auto rotation to landscape left and so on. You can turn those things off and on in code, right? Brightness, current resolution, and so on. Cutouts, return a list of screen areas that are not functional for display content, read only, right? So what does this give you? It's probably going to return a rectangle, exactly, right? So this is additional information for us to kind of indicate if there's a cutout or not, and what's the safe area, if any. And if there's no safe area, for example, if the rectangle for the safe area is equivalent to the rectangle for the screen, let's look at the actual screen itself. So there's the orientation. So screen orientation. Okay, now this is something else we can look at. Screen orientation. Maybe we couldn't detect the orientation change, but maybe what we can do is we can detect screen orientation in our editor. That would be very helpful. Let's do that. So thank you for that, Michael. You're awesome. Somehow you prompted me to look here. Screen orientation. Let's take a look at that. So since we're doing it, might as well do it, and we've got lots of time. So again, I'm going to go to, let's put this aside for now, and let's go to my game controller and look at my game controller. And what I want is inside of this stuff here, we have our some stuff. Let's just do a debug log, debug.log, and then we'll say instead of no, this isn't the switch statement. That won't work. Hold on a second. We want to do in here whatever the screen orientation is. Let's just do a debug log for now. It'll be really wordy for us, but we'll put out the screen dot. Come on. Screen dot orientation. Come on. Chug, chug, chug. It's taking its time. For me, anyway. Visual Studio. Oh, Visual Studio. There it is. Screen orientation. And screen orientation returns a screen orientation type. All right. ToString? Is there such a thing? Well, we're going to make it happen. How about that? Whatever that looks like, we're going to see if we can print out that screen orientation. Okay, because we don't know what that screen orientation type is. Okay, let's go back and try it out. All right, portrait. Look at that. Okay, so that is definitely a way to go. So what if I move it? Will it detect? Landscape left. God damn it.
You don't need the toString. It'll print it out normally anyways.
Okay. But damn it, that would have been better to know than device orientation, portrait, and landscape. I'm not sure that I want to change this though, because I have a feeling that this comes from the OS and this is something that comes from our editor, right? So, I mean, I could run a second switch case to do that kind of stuff. But one thing to note is we care about the screen orientation. So let's see if we can do it. We'll swap out input the device orientation and use screen orientation instead and see if that works on our devices. So, and then we can update this stuff. Screen orientation. So wouldn't be device orientation portrait. Let's see what that looks like. So do I have screen dot orientation left? No. How would I detect that? No. Screen orientation dot, it gives me that. Maybe I just have to say orientation left and right like a string. That would be poor. I'd rather have an enum. I don't think it'll do device orientation. That's not a thing for us because it's not a device anymore.
It's screen orientation dot.
Yeah, I'm gonna check.
Whatever.
Like all one word.
Like all one word.
Oh.
Screen
No,
orientation.
screen orientation. Because
Right,
it's a screen
right.
orientation
Dot
object it's
landscape
returning.
or dot portrait. Okay, let's see if this works. Thank you for that. So let's see if this works. And let's change. Well, that means that these are all going to be the same. Just we have to just change this from device orientation to screen orientation. I don't think this is the same effect, though. My fear is that if you were to do this, it would do something totally different. Because I know this works. This has always worked for me. But, you know what? Let's move and groove. I'm okay with changing stuff if it's going to be new and better. So let's see if this just pushes off to the... Because then we can use one switch case as opposed to two. All right, let's push this over to our little device, the Google Pixel 2, and see what crazy effects it has. All right, so... And then we wouldn't have needed the test button. Damn it! Okay, let's go to File, Build and Run. And then let's see what happens. Hey, but this is all good learnings for everybody. And what this does is it gives us more information about how we can use the safe area and if we have cutouts. And if we have that information, we can respond to it. The more information we have, then we can adjust the layout. And we'll use the same techniques we just used, right, to make things work the way we want. And this methodology actually works exactly the same way for the most part in native devices for both Android and iOS. Orientation change. And for the web too. Okay, let's check this out. All right. So it's bringing it up, start, and we'll go start. This is good. And if I switch around, then, yeah, looks like it's okay. It moved, and it moved up where it's supposed to be because it responded to what it's supposed to respond to. It doesn't have that big gap. So here, what we're going to do now is we're going to detect the, we're going to update our script to also include the safe area. If a safe area exists, right, then, and I'm wondering if we just can use to detect if a safe area exists. If the safe area exists, then, you know, we move things here. If not, then we move things somewhere else, right? We would move things more to the left and ignore the safe area altogether. So let's see if we can do that. So we don't care about this anymore. That's just going to cause us a lot of performance lag. But what we can do is we can say that, what about if there is an, can we detect the safe area? So if the safe area is there, then we'll do it. If not, then we won't. And we'll do it for each orientation change as an example. So we'll say if screen dot safe area, if it exists, contains, overlaps, position. Too bad they didn't have an exists. Well, if the rect, I wonder what the safe area would be for the rect.
If screen dot safe
that?
area. Couldn't you just use if screen
No.
safe area, and then I'll.
Yeah, that would be nice if we could do that. That's why, because it returns a rect, right? A rect, if it doesn't return a boolean, right? So we would have to do something like, it returns true if the x and y components of a point is a point inside the rectangle or not. Equals, we can do that. where I want to equal something else, like the screen dot, and I think there is a, oh, the other thing is cutouts. Cutouts is a rect, right? So that tells us where the problems are for the cutouts, because that's going to be different in the future too, right? But we don't care about being so specific with the cutouts. All we care about is orientation left or right and where the safe area would be. It's going to move, right? So, so wonder what we can use in terms of our screen. So orientation, brightness, and current resolution. Cutouts, so direct.
Couldn't you compare the safe area to the full height and width of the screen? And if they're not the same, then there is an area.
Yeah, that would be a rect. But the width and height would be a rectangle as well. We can make a rect. So maybe what we'll do is this. We'll make a... we'd have to make it up here in the update when there's an orientation change, right? That's another thing we have to think about. Only when there's an orientation change happening at all, if the current orientation is not equal to the old orientation, right? Do we want to switch orientations, right? That's going to happen on update somehow. But we need to detect and create a rect for the screen. So for now, in a very bad way, we'll make it so that we'll make a new rect object and we'll call it screen rect, right? We don't have something like that. Sure, we'll select their recommendation, screen rect. Does it have, is there actually a screen rect? Sometimes they have that. Nope. Screen rect is equal to a new rect, and we can put in screen dot width and screen, wait, what does a rect need though? Does it need a starting position or just width and height? It needs, oh, there's 3 overloads. Okay. It needs a position, vector, and a size. A position, vector, and a size. Or a float x and y. Well, yeah, this is useless. So, because then we'd have to compare, because a rect has a size, and a size is going to be a vector 2, which gives me x and y's. So, instead of doing this, we'll say, well, because you can't do a comparable that way. So it'd have to be the width and the height would have to be the same as the same. So we'll just make a thing. So say, sorry, just trying to think about what I would do. So if my screen dot width, I guess would be, if that's exactly equal to our screen dot safe area dot width, right? If that's equal to, and we also want to do screen dot height is exactly equal to our screen dot safe area dot height. If those two things are true, we know they're the same, but there is no safe area. So let's test that. Why is it give me that extra? What the darn it. Keyboard. All right, and if that's true, then I want to just test to see why is this giving me an issue. Equality compared to floating point numbers, partial precision loss. What does it recommend? Fixed floating point comparison with a tolerance. Yeah, no. It's gonna be the same because even though it's floating point comparisons, they're gonna be the exact same, or they're not. So if that's true, then let's say. We'll do a debug log just to test this out. Debug.log, and we'll say no safe area.
I just posted something I just put for the debug log just to see what it would give me, and it always gives the safe area. And if the safe area is the same size as just the screen, it matches. But if there's the difference, then you get the different numbers.
Right, but I'm wondering if this would, I'm comparing my screen width and the safe area width. Those are the numbers that I'm comparing. If those are wrong in any way, then there's no safe area, right? If they're the same, I mean.
Yeah.
If they're not the same, then there is a safe area, and then we can do something. I want to just test this out, but I see what you're saying. Let's just run this. There should not be a safe what? Oh. there should not be a problem running this right now. We should actually have no safe area right now because they're the same. Safe area and the screen size are the same size, or what it appears to be the same size. Yeah, look, no safe area. Okay, now let's switch to another type of screen. Let's switch to what we had before, which is a Samsung Galaxy S10 Plus. There is a safe area here. So let's run that now. That we should not see that anymore. Yes, see? We don't see it. So now we can detect the safe area, which is different. So now that we know how to detect it, this is a way of doing it. We just do a little thing that says, are they the same? And if they're the same, then there's no safe area. And if there's no safe area, then we should set a flag or something like that. And I'll probably do it up here because I don't want to detect that for everything. Right? I don't want to do this check every single time. I want to do it once. Right? So I want to do a flag. I'll set up a Boolean, a private Boolean, which will be a has safe area. And we'll make it equal to false. Or maybe true. It doesn't really matter. Anyways, we'll say has safe area. If there's no safe area, then it is a thing, and otherwise it is false. So we can do a ternary operator to do that here. So we can do something like that looks like this. We can say that has safe area. Visual Studio. Tom too. Has safe area is equal to this. So this means that there's no safe area. Then there is false, else true. And that would do what we need. Let's check that. So if these are equal, then there's no safe area. Or it's true, there is a safe area. There we go. And I don't like the way that my resharper coded this. I want to put it on one line. So this checks to see if there's a safe area. Checks safe area. Okay, so now if there is a safe area, if it has a safe area, then we want to do these values. So if has safe area, then do those values. Otherwise, we want to adjust these values here to something else, not just for portrait, but for everything else. And we're going to do an else statement for the other stuff too. So something that looks like this. As long as you guys agree. Do you agree? What are your thoughts? Because you guys are coders too, man. This is a little bit of, and we may also use some kind of function to, because basically what we're doing is we're adjusting the same thing over and over again, right? And it's the exact same code. When I have code duplication like this, in my mind, I'm thinking there's got to be a function for this, right? There's got to be a way of me, if I have my safe area, to send values across to do something like this once, as opposed to do it multiple times, like how I'm doing it. Right now, remember my other motto though is make it work. Make it work first, and then refactor later, then optimize, because you don't know if it doesn't work. You don't know if it works yet. All right, so now what I need to do, if I don't have a safe area, is change these values. Change the values so that I hug right to the top, right, kind of stuff. Oops, let's move this so it's closer. And then we should be much better off. And I mean, again, this might be, you might think this is might be a little bit overkill, but my thoughts are I want to provide the best layout possible, right, for my my user, right, my player. So if has safe area, then I do it, and it's going to be different depending on if I'm landscape or portrait. So that's why I have to do this check every single time, right? Could I do it differently? Yeah, I think so. I'm probably going to think about this again. All right. Anyways, let's get to it. So portrait. If I have no safe area, how will it look? Let's move to a phone that doesn't have a safe area, like for example that Google Pixel 2, which is what we had before. So in the case when there's no safe area, what I want then is these values here to be way up at the top. So I want this to be here. So my X value is going to change to minus 77. Or my Y, I mean. So if there's no safe area in portrait, instead of it being minus 200, I'm going to go to minus 77. Okay, so that's this part. And let's just run this thing and see what happens. Let's see if it detects that there's a safe area, and this part runs. One thing at a time. So what I want is I'm not going to modify my layout. It's going to modify things for me when I run it. Let's try it. Yeah, right? So that kind of worked. And again, if it runs here, it's going to run on my phone too, theoretically. All right, now landscape left, but there's no safe area. Okay, how that works. So there's no safe area. I might as well use this one too. Let's rotate to the left. There's no safe area, and that means that this has to be up here, and it's got to be hugged right to the left side here. So again, this value here has to be right here. So it's at minus 81 on the Y, right? What it looks like, and 248, minus 81 and 248 for that one. So again, landscape left, minus 81, is that right? And 248 on the left. Okay, that makes sense because 248 is the leftmost value, right? But I'm not sure why minus 81. I'm not 100% comfortable with that. But anyways, let's get back to it. And then obviously this is going to be...
Sorry to interrupt. You can just do it mathematically, because if you want it into the corner, then it's just half the height and width of the label.
I could.
So they should be all negative 80, because I think it's 160 tall or thereabouts.
I could, but I'm just trying to do it by eye, Russ. So you're right. I'm gonna, like I said, I want to make it work, and then afterwards I'm gonna go there and do some nice stuff that you're doing. All right, so let's see what that looks like. Minus 81 again. Isn't that weird though that I'm getting 83 and 81? And I'm wondering if it's the phone that I'm using, right? And it is minus 353, so that doesn't change. All right, so let me undo those changes. But yeah, you can totally do it mathematically. That is definitely a way to go. And let's go in the other way. So this is the other thing I care about. So this would be okay. Minus 81, 248. That looks like it's exactly the same. In fact, it will be the exact same because there's no safe area. So I can just copy this and paste it. There, right there, there is a optimization I can make. Because this would be the same.
Would it be better to have like a safe area offset that you calculate? Because different phones could have different safe area sizes. So this safe area will work for the S10, but what about a different phone that has like a different... I think it does that. I think it calculates the safe area based on that. But yeah, you might be right. I mean, I want to see what happens with this thing. Like, if I have a different phone, will it, will it respond good? And would it be good enough, Michael? How about that? But yeah, having a safe area offset. I mean, you basically what you do is you calculate the difference between the width and the height, and then that would be your offset, right? And then if you have a safe area on the left, you'd move it over X number of pixels based on the safe area offset, the difference between the width and the height of the width of the regular screen and the safe area width. That would be the way to go, for sure. Okay, well, let's see how this works, because it's pretty bad, but hey, let's look at see if it is okay, right? So let's go back to this way. All right, and we'll undo that. Change, go here, and we'll run it now in this mode and turn it all around and make sure it works. So that worked. And we'll turn it this way, and that looks okay. Much better. And we'll rotate it the other way, and that looks okay because it's the same. And we know we don't care about upside down. So that's pretty good. All right, good. And now we should probably push that across. What about does it look okay with other phones? So this is going back to what Michael is saying, which is what about the safe area if it was different sizes? Like, for example, the iPhone 6. How does that work if it was an iPhone 6? We don't have one to test right now, but let's see how that looks. And that looks not bad. I mean, I probably could have pushed it over a little bit more, but that looks like it's pretty good, Michael.
It looks like it's probably a little bit too close on the top there to the actual phone itself.
But more like the XR.
But more like the XR, because that one has a different form factor of the cutout. This one is like
Let's
the
do it.
Pixel 4, where there's no safe
iPhone
space,
XR.
right?
There's the iPhone X. There's the safe area. That's going to look okay. Right? And then if I go to the left, then it should cut out. Look at that. Looks like the safe area is pretty consistent.
The score will be wrong, though, if you expand it.
Oh, is it?
Yeah.
Oh, yeah. Look at that.
Yep.
Because we didn't account
for there being safe area on left and right.
That is very true.
So here's where you do it
So
mathematically.
here's where you do it mathematically, where you move
No,
everything
I
by
don't
their
want to
half
work
sizes
so
and
hard.
safe
I
area scales.
refuse to work so hard.
Why wouldn't you do this from the beginning?
Why wouldn't you do this from the beginning, though? That's
Because I was thinking about,
It's like,
you know
I
what,
don't
man?
know, because you have no way of knowing where
Everybody
the,
thinks
physically
about
where the
things
safe area is from left to
differently,
right.
Russ.
So you'd
You're
have
right,
to
you're
use its
absolutely
points.
And I just didn't think of it that way. I thought of it this way first. And so, because my mind is thinking, hey, you know, probably I'm not going to have a safe area on the bottom. Probably, right? But like you said, you just pointed out that it's wrong, right? So, and what if in the future we have another device that has cutouts on both sides, right? Or cutout on the side here for some reason, some weird device or a fold or something crazy, right? So yeah, so we should basically use mathematics instead of what I did, which is moving things by eye. But it does all right now, for the most part, other than this part, which is weird. Why would the iPhone do that? Oh, by the way, I know why the iPhone does that. Does anyone know why?
The swipe up command.
Yes,
swipe up
the swipe
commands.
up, because you're going to put your finger down there and you're going to swipe up, and you need that area to be free of the game that you're running, right? And that's why this is the way it is. So, to your point, what you'd want to do is you'd want to have a safe area calculation. Now, on the right, I'm not sure why they would do this. Typically, we wouldn't do that, but I guess Apple has a different way of doing their device configurations for this. Let's try changing the size to something else other than an iPhone XR. Let's go with an iPhone XS Max. And again, it looks like it's the same thing for Apple devices. So that's something where you'd have to calculate. Okay, you've convinced me. We still have 25 minutes. Let's go calculation-wise. So let's go back to the other way around, and let's fix it now. Because you're saying, because this is working. The detection, the mechanism that we've used, it works. We'd have to do more work to do it my way than to do it your way. So now we're going to go revert. And we're going to do some extra work, but it's going to work better in the end. And we're going to have a better solution in general. Okay, so what we want is an offset that we're going to calculate. And we're going to do that on update, right? Because just like it has safe area is one thing, but we don't care if there's a safe area or not. We'll just calculate the offset. If the offset is 0, we'll add 0. If the offset is something else, then we'll add that offset. Make sense? Russ, would you do it this way too? What are your thoughts?
Sorry, I was writing.
No, you're not allowed to write.
I didn't. I was listening.
Yes.
Oh, I'm going on ahead and doing
Oh, I'm going on ahead and doing this. What?
What I said was,
I'm creating I created values for the half height and width of the labels.
oh, you're doing it that way.
because I'm going to be
You're doing
referencing those.
I'm saying
Yeah,
var
and
offset
then-
offset left, right, is going to be the, or because there's the left offset. If there's a, but that, see, that's the thing, is like it's going to be a different safe area based on the position of, Daniel's coming back in, based on the position of, on the left side, where it is, because on the left side you're going to have a starting value, right? So
You don't need to. It doesn't matter though, because you're basing everything. You're not basing everything on the screen. You're basing everything on the safe area, which has its own rec. So you just need to know the half height and width of the labels themselves, and then set their position to the safe area plus or minus their half sizes to align them to where you want them. It doesn't matter where the safe area is. You already know what the safe area is.
So what you're saying is you're using the position of the safe area, and
Actually, I gotta double check that.
I don't know if
It
the
does.
safe, because it gives you the size of the safe area. I don't know if it
no, it
tells
does.
you where
It does.
is.
There's a rect. So if you go to screen.safearea.rect, then you can also get a position. Look, there's a position a vector too.
Oh, okay. Then yeah.
Oh, okay. Then you take the position
Yeah.
then because we want it in the top, so it'd be its position
on the x-axis
plus its height minus the half height.
But that's
of
just the label. That's just the label, right? We want an offset for anything, right? Because it may not be the label.
But you don't know. But everything is a different size. There is no offset for everything.
You can get the
offset of the distance to get into the, you know, from left or right of the safe area. But then you still got to do the math based on the size of the object you're trying to center.
We'd have to make a function for that. That's
also,
what
I would be doing this in
also, I would be doing this in Start, so you're not constantly calculating the stuff in the update.
But the problem is that the safe area might change if you rotate your phone. If you rotate your phone, then your Start would only work. This is only triggering once, right? Update is going to trigger every single time.
Oh, right. Well, yeah. Okay, yeah, for the...
Yeah, you have to make the safe area change every single time, because if you rotate your phone, if you're going to be responsive, then you're going to change your values every frame, right? But the thing is, what you want to do is, we want to detect an orientation change. That's something else. We'll do one if statement that says if orientation change, any orientation change, then we change to see what the orientation is, right? So that's something we can, like an on orientation change event. And I'm wondering if there is some. I'm betting there is, because there's no way that we're the only people that are doing that. So on orientation change, sure, for Unity. I bet you there is such a thing. Just an orientation change. Input device orientation. Well, we did that already. But that doesn't change everything. Screen orientation. But I'm wondering if there's an on orientation change event. And I'm guessing there is. Something else like that. Yeah, device orientation we've already done. This isn't what we want, though. We'd have to make our own. Which is not a big deal. Anyways, so my thoughts are that I want, right now, I want to get an offset. The difference between the width and the height, right, of the safe area. Assuming that we can't, and then we have to balance the difference between the screen position. Can we get the screen position? Not the screen area position, but the screen position. Screen dot position. No, because the screen position would be like 0, 0, right? So that's something we can get. If we take 0, 0 as the middle of the screen and we get the position of the safe area, so we say that var position offset, if the position offset, that's going to be equal to the safe area. So screen dot safe area dot position, and that's going to be, it's going to move up whatever that distance is, and we want half of that, right? So multiply by 0.5. So that is going to be the position offset. Wait, position on the y-axis and the x-axis. That's right. So I move one, and then I move the whole thing. No, I want the whole position, because if I move up the whole thing, no, I like your idea. Half. We'll add half. So that is going to be the position offset, which is going to be a vector 2. Okay, so that is going to orient whether I'm going to be in the middle or up or down based on where the safe area starts. So if the safe area is moved to the left, then I'm going to move everything to the left. That's going to be the offset. So let's, I'm just curious what that would do for us. So if I'm rotating to the left, then if I'm landscape left, right, that means my safe area is going to move to the right on the x-axis. So let's output that just to see what that looks like.
I found one solution where instead of having an offset, they change the anchor points of the canvas. So that way,
that's the whole canvas moves, in other words.
Yeah,
Yeah.
it like resizes to fit the
Again, it's
space.
very similar to what we're doing, though, right? So position offset dot, we just want to print out position offset. Do I have to do a 2-string? I'm not sure. Let's see. Oh, that's not what I wanted. No. Press. Go. And do we have a thing going on here? Where is my console window? And Russ is probably furiously writing, and he's probably already done.
No, I ran into a problem, but I fixed that, so I'm still working on my end.
Hold on. I'm gonna see if I can do mine faster. How about that? Probably not. Or may not work as nice. All right.
Probably will. I'm still calculating some things.
Why did that not work? Wait. So that should. Let's take a look here. Position offset didn't print. Why did the position offset not print at all in a debug log? Did I save it? Let's go do a 2-string. I don't think I need that, but let's see what happens when I run that. All right, look at that. So 66 and 31. So from the screen center, so I'm losing, yeah, so that is my X and Y. So if I divide that by 2, that means, okay, so there it is. So there is the, on the Y axis, I've moved up 31, what looks like 31 points. Call it whatever you like. I'm not sure if it's pixels, but it's 31 points up. If this was 0, and let's see if it's another device, like a, for example, a Google Pixel 10 Plus for a second. Just want to see what the difference. This should be 0. Yeah, see, that's 0. So then 71 is, I'm moving to the right 71 pixels, and that's your offset from the center of the screen. So the actual center of the safe area is way over here. So I'd move everything over 71 pixels, right? Because the whole thing is moving over 71 pixels. The only thing is that I would want to move only the left label 71 pixels to the right, because not the right label. Okay, so how would that do for the, what would that do for me if I had both the left and the right moving over? Yeah, so that's a boggle, because I'm just comparing widths, right? I'm just comparing positions, actually. That's all I'm comparing. So this basically says that the position is to the right. And now I'd compare widths. So now I lost width, and I can see if I lost width, all right, and if it moved to the right, then I would subtract those two things. So then, okay, so what's the width? So if my width went down, difference in width. So this is the position offset. So position offset works out to be a vector object, and then my width, I think we're gonna have to be continued, guys, for something that's perfect. But for your lab, it's pretty good. So we're gonna say the width offset, right? Or the width difference more than anything else. Difference. Width diff. How about that? Width diff. Say that 10 times fast. Is equal to the screen dot width, and we'll minus, because that's the full width, minus the safe area. Screen dot safe area dot width. So that's going to be this width offset. And what about the height? You could have a height offset. So height diff is equal to screen dot height minus the screen dot safe area dot height. So that would give you a height differential, if there was such a thing. And if there was a height differential and we shifted the middle of our area, that means I would have to worry about the bottom, because the bottom would be of different size, right? And I'm using vars because we can quickly detect what these are, but we can always put these back in as vector, oops, just like autos, for those people who don't know that. And that's what those are. And ReSharper says it doesn't like width diff, but it doesn't matter. Okay, so width diff, position offset. So if my position offset goes this way, and if my position goes to the right, and I have a width difference of, if I have a width, I subtract my width difference, right? So let's say, for example, my width was, well, let's see what those values are. So what is my width difference?
For the safe area,
there's an X min and X max
feature available as well.
In safe area?
Yeah. So if you do the X min, it'll tell you how far to the right it is from the left edge.
And is it a Y min and Y max? Well, we don't even need all this stuff then. If that's what it is, then we just have, now we go back to what Rust did, which is we get the X min and X max and the half the width of the labels, and we're done. Because that's where it would start, and then we'd add a label to the right or the left, and we'd have to do any of this stuff, really, at the end of the day. Right? We'd have to even do these, like we don't have to even do the orientation changes. Because if there's no safe area, then we don't care, right? It would just link to the anchor points. So all we care about is the width and height of our labels. Lives label width. Let's do this. That's a one-time calculation. So we'd say like we would make that a floating point number. So private float, which we would say we'll call this the lives label width, because we don't care about we also care about the width and the height, right? Width and the height. Would we care about the height? Because we move it up half and move it down half. Yep, we would. Lives label width and height. We care about half width and half height, because we don't care about the whole width and the whole height. So we just calculate that. So lives label half width and private float. We probably can create other structures this way. Lives label half height. Maybe a size, a vector for these two things, like a size. But we have that already, right? Do we not have a lives label size? Let's check that out. Lives label, because it is a game object. Dot size, font size. Dot width. Right, transform dot, no. Bounds. There is something called bounds. Bounds dot.
Would you just have to get the rect transform component?
Yep. But the rect transform component dot, it gives us
and then you just have your width and height.
Yeah, it just does it though. I don't think it has a width and height. Look, rect transform dot, because inside the sorry, I'm going to time out here, and then you guys are going to have to go. But if I look at the lives label, it has a rect transform, even though it has width and height here. I can't get at those values. There's something else. Look.
That's what I got stuck on. It's rect transform dot rect dot width there dot height.
Lives labeled that width, and that's it is, and then multiplied by 0.5. That would be the half width. Lives label half width is equal to. We want to calculate that once, right? So that would be done in your thing here. And lives label half height. That would be your lives label dot rect transform dot rect dot height multiplied by 0.5 f. Yeah, so that would be that, and then we do the same thing for. But you could probably create a vector for this. Score label. Wait. Score label half width. And private float score label half height. And let's try and calculate that. Score label half width is equal to We'll just replace this with score label. Score label. And the same thing with score label half height. Alright, so that gives me my half width and half height once. We calculate that one time, and that's never going to change because these are constants, right? Unless my labels are going to fluctuate or get bigger or smaller somehow. Don't need this anymore. The has safe area, because we know if it does, then this part here would work. And since we have our screen dot xmin and xmax, right? Then what we would do is we wouldn't even care about all this orientation change stuff at the end of the day, correct? I'm going to comment it out. But we don't need this because what a change, eh? If we get this working. Because then all we care about is moving the labels around. So so the position of the label, which would be the anchored position, would change according to the xmin and xmax, right? So we would say that the lives label dot rect transform dot anchor position, right, is equal to a new vector2 object, and now we need the x and y values. That would be the screen dot safe area dot xmax xmin, because that would be the lives label would be on the left, xmin, because that's what we care. It's specific, like Russ was saying. Xmin is the x-axis, right? And that would be the left side of the label plus half the width, plus lives label half width. And then the y position would be the screen dot safe area dot and this would be the y max, because that's at the top, y max, right? Y max, and then it would be minus minus the lives label half height. And that would be your, it's a one-liner. And the score label, wow, what a revelation. Score label dot rect transform dot anchor position is equal to a new vector2 object, where we'd have the screen dot, now this is the on the right hand side, so we care about the safe area dot x max on the right hand side, and then we want to go back the other way, which is minus score label half width, and then the screen dot safe area, I think it's the same for this one, dot y max. Let me just copy paste. This is the same because we don't care about the bottom. These things are at the top, and that should do it. If Michael, you're correct, and Russ, you're correct. If not, we're no worse than we were.
I hope it works.
I hope it works.
Because 2 lines.
I think the math is slightly off given
No,
that fight.
no, it
because
cannot be off.
It's what I'm trying to solve right now.
It's what I'm trying to solve right now. No, it is, because the anchor point is in the top, so we're going negative from that, but we're calculating with the y of the height and the y of the safe zone, which is counting from the bottom. So I'm trying to figure out the change in that.
Wait.
It's throwing off my position.
It's throwing off my
Yes,
positioning.
that would
I'm trying
work.
to solve it.
So it would be left, and then if the thing was to the right, it would be a positive number. So for the left anchor, the left
The left and right works.
The left and right works. It's from the top is the problem.
it'd be a negative number from the top, because the top is gonna.
But it's not the same.
It's
not just a matter
Let's see
of
what
making
happens.
it negative. That the math
Let's
doesn't
see
work
what
out that
happens.
way.
Maybe you're right.
I'm trying
Maybe
to
you're right.
solve
Maybe
it
you're
right
right.
now.
Hold on a second. Right.
The issue is the width is like 500, but when it's scaled down to our screen size, it's completely different. So when we're adding the half height is like 80, and we're just shooting it above, and like the half width is also really large, isn't it?
Mine's not that far off, but I'm also not using the X min max or whatever
Well,
you guys are
actually,
using.
it's it looks like. I mean, where is my other label? My score label. Where did this go? It's way over here.
It's at
Oh no,
thousands way
okay.
up there.
I understand what happened, but so how the heck did that go back this way? So where is the X min and X max then? That's messed up. This is okay. Look at this. That position looks fine because that there is a bit of an offset, so this is good. The like you said though, minus this doesn't make any sense because then we're getting a really weird offset, and that's the anchor position, right? I wonder if you have to use, instead of anchored position, sorry guys, I know we're timing up and this is beyond what we wanted to do, but we're trying to solve it with one line of code. This is the refactoring piece, right? I wonder if it's local position, guys. Instead of the anchor position. We don't care about the anchor position anymore.
Well, that's what I'm saying. Because
Well, that's what I'm saying, because it was based on anchor position, the change is
Let's see what
weird.
happens now.
I just blew up mine.
I just blew up mine. What happened?
That doesn't make it any better.
My regular position.
My regular position
Oh,
works.
regular position. Like
Yeah.
position. Okay. Maybe
Yeah.
that-
Not local, just position.
Just not local, just
Yeah, well,
position.
because we
Just the
because
score
we
looks
don't
a
care
little
about the
off
anchor
with that.
anymore, right? We're actually doing. Oops, God damn it. We don't care about the anchor position anymore because what we're doing is we're. Oh no, but then it's way off. Look at that. But it's not that off. It's just transformed to the right by what looks like the. The difference in the position of the like it's a consistent value, right? Because it's off screen, but it's off screen the same, not like before. So where is that? That is the X position is.
Mine isn't giving me
1912.
that.
Mine isn't giving me that
Okay.
issue.
I don't know what
Did I have a
it-
different
I don't know
calculation
what I
than
did.
you? Here, this is what mine looks like. What does yours look like?
Oh, I did.
I did.
Hang on, I had a
Hang on, I had a bad number here.
Because that's so the left. What my thoughts were, X min would be the left side, right? Plus my lives label half width, so that would move it over to the right, right? But this is assuming that it doesn't already have a default value. And just curious, I'm just curious here. I want to do something else. One more thing. What if I change the anchor position to the middle for both objects? So if I said since we're going to change them anyway, this will be the anchor position to the middle. Let's see what happens to that left object. Let's see what it does. Because I can always switch back. Does it affect it in any way? Yeah. What? Wait a minute. How did that? What the?
Yeah, mine's been working.
Yeah, mine's been working fine with the anchors
Wait.
even set. I don't know if you just didn't save it or something.
That.
I'm still up.
I'm still off. I'm still
Wait.
trying to get mine
Okay,
to
so
line
hold
up
on a
right.
second. So there's this, and then I run it, and it works. How did that work? But didn't work before. Yeah, I was right. I was right the first time. God damn it. But with position, not with anchor position, Michael, like what you said, right? All right, so then hold on a second.
Yeah,
That's the S10. Let's go with a smaller phone. Let's try the iPhone XR, which is what we had a problem with. All right, let's run it. Oh, that's messed up. That's messed up. And what happens if I go like this? Yeah, that's really messed up actually. Look at that. Why is that? Like that should be right hugging the screen if going with the same display. I wonder if it's only here but not in the simulator. Because remember, this is based on this device, and it may not work the same in the simulator. Let's try it in the simulator. Because that would be like a... Remember, we are seeing differences with one device or the other, right? But that doesn't make me happy. Let's go back to the middle.
At least it'll work on all the.
At least it'll work on all the Androids, and we don't have to
No,
worry
we
about
have to
iOS.
worry about everything. For completeness, we'd have to worry about everything, right? So it must be something different than the iOS on the other iOS side. Okay, so let's push it over to the device that we have. So let's see if it works here. So we're going to say File, Build and Run, and this will be a great learning experience for everybody, me included, because I didn't know these things existed, and that's a good thing to learn. But worst case, you can always do your if statements. I want to see what it does when I push it to the device. I want to see if there's a difference with what we're seeing in the on the Unity side in the editor and what we're seeing on the device. But anyways, for your lab, doing what we did earlier with no adjustment to the safe area is good enough. Because it's like a minimal, like really, it's still minimal code.
I think it's because like
the iPhone has the smaller screen size, but the label size itself doesn't change according to the screen size. So we're still moving it to the right the same amount. So because it's a smaller screen, they're more wedged towards the middle, whereas if it was a larger screen resolution, it'd be more towards the left.
All right, let's see. Well, that looks okay. Look at that. So that, although I would have liked to see, this is the actual device. So actually what I'm saying is it's not as nice, but it's even, at least, on the left and on the right. I mean, it's still not a bad solution, this one that we came up with, right? Again, as a preliminary, right? So it's calculations as opposed to orientation. We don't care about orientation. We just care about the size of our the rect of our safe area and where it is. And once we have that, then we just orient according to that. Although it works for labels, I'm not sure how that's going to work for your background image. That's where I would probably have some if statements in there. But we can probably use something like that too. So if I go back, and that should orient back the way it was. So again, not so bad. It's not great though. We're still having a little bit of a buffer on the right and on the left, like too much over here. And this is the actual device, right? So let's try it now on another one. I'm just curious what it's going to look like on the S10, right? Because that's something that we would have to check too. But this is all good. This is like, again, for me, it's all learnings. And whenever I have this kind of stuff, then we can think about solutions, right? We have a problem, and I'm sure someone's going to come up with it. Make a panel equals the safe area size, put everything in that. Yes, yeah, you could do that. Because the panel is another option. The only thing with the panel that I don't like, we'd have to make the panel fully transparent, right? Somehow. Unless you like the panel. It's a container. Let's see what that looks like.
Tom, I think the issue is with the scaling with the screen size, because
we moved to
our image itself of like the lives and the score scales with the screen size, but the width, the half height and half width that we're doing never changes. It's always the 500 width.
Correct. Yeah.
So on
a smaller screen resolution size, it's looking a lot more right than it should be, because that 500
but
never
it would
changes.
change, and we have to modify the size according to the. So our width and height, our half width and half height are the things that are problems, because we're pushing over too much.
Wait, why would they change though? The label size never changed.
But they do on
or is the label getting shrunk with the smaller screen sizes?
They would the screen size would change everything. Looking for Kat. The only thing with making it fully transparent, I think it makes all the children transparent too. Let's take a look and see what it does here. So this is okay. That's actually a really good position. Let's see what happens when we do this. Not quite. So again, what we just said, which is it works okay here, but it totally didn't take into account the safe area here whatsoever of this thing. But I mean, it looks good in the simulator. It's just not, it's not quite right. Although it looks much better here than it did without it. So going back to that then, we have to adjust it. So one thing we're missing, this is the calculation, is inside of the canvas area, and then we'll stop for today, guys. We went way above and beyond. It's match width or height, right? So what we need to do is, this is the reference resolution, and what we need to do is we need to change the aspect, the scale. That's what this is. That's why it's called a canvas scalar. And I'm wondering if we can get the new scale based on from the canvas scalar. There must be something we can get out of this thing. So let's just curious. I'm going to look at that now.
I put outputs on the half width, half height, and they never change for the different screen sizes.
You put what on the?
I just put a debug.
I just put a debug, just output whatever we have as the half width, half height.
They wouldn't change.
They never change.
No,
They're
because
always
it
the
measures
same.
the original label, right?
Yeah.
So what we need to do is measure we have to get the ratio of the scaling that happens with the canvas. So let's just do, if I was to look at the canvas, right, and if we look at the canvas, it's the canvas scalar dot, I wonder if scale mode unit, what is unit? Enumeration. No, that's not what we want. We want something else from it. So let's suppose, let's get a reference to that thing. So we're going to say that we're going to make a public reference to a scale, canvas scalar, which we're going to call scalar. And let's suppose we get that, and in the start in here, oops, that would only happen once, Russ, because you're not going to rescale your screen. It's going to be the same scale every time, right? So scalar dot physical unit scale factor. There we go. Look at that. So scale factor is a float, and that'd probably be, would it be the same for both? We'd have to look up the, we're just guessing here. We'd have to look up the API for this thing. What else did you get? It's scale factor. It should be a vector. Scale. UI scale mode. No. What else does it give us? Default sprite DPI, physical unit, screen match mode, reference resolution. We can get the reference resolution, reference pixels per unit, match width, and scale factor. So if you took that scale factor, let's print that out. So if I said scalar.scale factor, let's print out that every oh, actually we do it once. Scalar.scale factor, and let's print that out in a debug log. And so let's do that. If I can actually type properly. It looks like I cannot. Debug. Wow. And we need to do that inside of this. We have to make sure that we get a reference to in the game controller of the canvas scalar, which is going to be here inside the canvas object. Just drag and drop. So now that we've got this, and if we run it, we should see that this, what the scale factor is for this phone. It's 1, because that's, we're using this as the reference phone. Okay, what if I go down to, if I change this to 4? And let's change that to a 4, note 4, and then run it again. Still 1. That doesn't make any sense. Do it change afterwards. Thanks guys for sticking around. If you want to go, if you have to go, totally fine. I'm figuring this out, and I'm recording it for you guys so you guys can have a better experience. Let's use this thing and try it again. No, that's not it, because it gives us 1 all the time, unless it changes after it's been instantiated, which means it would change every frame. but I don't believe that's the case. Scale factor 1. We should see ones. Yeah. So scale factor 1, because in our canvas we said that the scale is this 1440 by 3040. They must have a. We must be able to do something there with that. Reference pixels per unit is 100.
I gotta go to my next class, but I've almost
All right,
got it.
man. Good luck. Post it. Post it for us.
Because I think I realized another thing is when it rotates, the height and the width of the safe zone changes, but the height and the width of the camera screen
Right.
doesn't. So height is still the length.
So you
have to change what you're using your math on for the, at least for the right side, because it's all the way at one end.
Oh, that's a problem.
Russell, there's no Philip class. He canceled.
Oh, he did?
Oh, he did?
Yeah, he did.
Yeah, he did.
Oh no.
Okay, well we're still recording this on live on YouTube, so let's see what happens.
Well, then I'm gonna keep
All right,
working
let's see
on
if we
this.
can figure this out. All right, so but yeah, so that scale factor didn't do anything for us. This thing here didn't do a darn thing. So I wonder. Let's look at the scalar. Let me look at the API documentation for this. This is the best way to do it. So it's part of the canvas scalar. Canvas scalar unity. So I was just looking at that earlier today. Match width or height. Setting to scale the canvas to match the width or height of the reference resolution or a combination. Physical unit to specify positions and sizes in. Okay. Reference pixels per unit. Reference resolution. Scale factor. Scales all UI elements in the canvas by this factor. Screen match mode and UI scale. So this is the properties. But can we get per frame checking, inherited members, this is just stuff that we can get from anything. Print, destroy, instantiate. There's some operators and messages like we see in everything. So this is not really going to tell us anything, right? So how does it work? Screen match mode setting. Screen match mode. Scale factor is just a float. Canvas scalar. Yeah, I'm not getting anything different there. I think we have to do our own calculations, guys, because we have a reference resolution, and then what that would do is we take our new resolution, and then we also have to take into account our. I mean, I think we're overthinking it, but it'd be nice if the canvas scalar gave us something back, like it actually. Because the protected methods that it has are things that inherit from it. Constant physical size, handle size of screen, and these are the inherited members, the transform, all that stuff. And here's the public methods. But public methods are based on the inherited members. There's not specific stuff to the screen size. Start and stop coroutine. We don't want any of that stuff. Hide flags. That's the scale factor of the canvas. But our scale factor is 1. It always shows scale factor 1, a 1-to-1. So we want to scale it down. So if the percentage on the width and the height, we want to scale it according to the width and the height. Wouldn't that skew the canvas though? That might skew the canvas. So that's one thing we can do. We can say that we get the reference resolution and the current resolution. And we'd make a ratio between the reference resolution and the current resolution. And that would be your scale factor. And they would scale the labels, the width and the height of the labels according to that. Because we're not going to get it here from this. So we're going to say something like scalar dot reference resolution as an example. And this is only going to take care of half it, not the pixels per unit and all that stuff. The reference resolution, and if we subtract, if we put this over, no, that would be the denominator. So whatever the reference resolution is, that would be we would take the current resolution. So screen dot resolution, current resolution, divided by this, the screen scalar resolution. Can we do that? This is a resolution, and what's this one? This one's a vector 2. What's resolution? Current resolution dot width and height. Oh, we'd have to make a vector. Do we have a vector? A refresh rate and a width and a height. Okay, well, let's make a new one. So we'll say var current resolution is equal to screen dot current resolution dot x. We'll say dot width, and that's the x value, right? Width and height, and that's a vector. So that would be a new vector, width and height. Screen dot current resolution dot height. And we'll say that's a new vector, which would give us that value. And once we have current screen resolution, we take that current screen resolution, divide it by the scalar, because they're divisible, because they're both vectors at this point, right? This is a that's a vector 2, and so is this. And then we'd say the scale is equal to this. So that's the new scale. So scale is equal to this. Okay, let's print out what that is. Debug.log scale. And see what that is. And see if that makes any sense. Does that compute? There's no point making an adjustment unless we know. Yeah, 0.8. Look at that. 0.8 and 0.8, dude. So what if I was to move to another kind of phone? So that's 0.8. That means we'd have to subtract, we'd have to multiply the width and the height by 0.8. Okay, what about if I went to, instead of a Google Pixel 4, we went to a iPhone XR and ran that. 0.6. So that seems to work. 0.6, so smaller resolution. All right, and what if I went to an iPad? So an iPad Pro 11. Okay, and run that now. 1.2 on the width. So, but it would skew the crap out of it, and 0.8. But we don't care. We're not going to actually change the label size. We're just going to move the label according to what it is. Would that make sense? Because that looks pretty good, actually. Well, let's do it. See what happens. So I've got a scale, guys, and this scale is something that I can make up here. So we'll call this a. I need this canvas scalar because I'm getting from the canvas scalar. I'm getting the current resolution. So I'll say public. We'll call it screen scale, or just call it scale. Not scale mode. We'll make it a vector 2 scale, and we'll make this that. So scale is equal to this. And then what I want to do is I want to do this first before I do my calculations with my width and my height, because I want to have this value. So scale, and then for width, we multiplied that by the scale dot x value, and we multiplied this by the scale dot y value. This is going according to what you said, Michael. All right, let's see if how that works now. And run. Okay, so that put it right up there. A bit of a kerfuffle on the left and the right, though, for the iPad, but it's right at the top now compared to what it was before. Okay, what about the iPhone XR, which we had a problem with before? So that looks pretty good. The iPhone XR works nice. And what about a non-iPhone, like a Samsung Galaxy S10? And that should be a 1-to-1 ratio, so that should be pretty good. Yeah, looks okay. Actually, it looks like it's working, guys. So I actually spaced down a little bit, though. Let me see that. So a little bit down from this area here, so about half a width. We could probably adjust it a little bit. And what about the when I go to the left? This is the big thing. So if I rotate left, so that's pretty good. Programmatically, it looks like it's okay, right? Move to the left side. And what happens if I go to with an iPhone? Let's take a look at the iPhone now. Yeah, look at that. That's
In the canvas, I don't know if we have to make the width and height tighter fitting to the labels itself.
it could
maybe.
be, yeah, because the actual width and height are actually adjusted a little. Like I said, we could do a little bit better than this. But actually, dude, this is it.
Yeah.
This is we figured it out. Because this looks like it works for all resolutions for all devices. Let's take a look. Well, as far as we're able to test here. So I'm just looking at different phones. That was weird. I'm not sure why it did that. And when we're right to the top, the Huawei. What's the resolution difference? It might be a really weird resolution too. Because this should just go straight up. And a little bit to the right with because there is no safe area. So this should go right to the right. But it's pretty good. I want to see what this does. Yeah. Oh. See. It didn't quite do what it's supposed to do.
Well, it's based off that.
It's based off that green
Yeah.
rectangle, isn't it?
So then it is.
So then it
Yeah.
is.
We're not
'Cause
getting any information.
we're not getting
We're
any
not getting
information of
information
that.
about the cutout because that's not truly the safe area in this case. So again, I mean, it's with the best information we have based on our device simulator, which is in preview mode, by the way. So it's not bad, right? I mean, it's not a terrible solution, I think. So let's try and push it across to our devices, see what it does now. If is it better than this? Because I think it's going to push it down just a little bit. But let's see how it works. So build settings, build and run. And then we'll try it on the other device. Let's see how it looks. And I think this is good. Yeah, I will. Will you post the working code for the safe area? Absolutely. That's what the idea is. I'm going to post this up on GitHub in a second as an alternate. And I think there's some optimizations that can be made, and I think also that when you have a background image, that's something where you'd have to look at the orientations. Like actually do orientation left, orientation right. Because that's going to be different than moving labels. Moving labels is only one aspect of the problem. The other aspect is the background images. And speeds and all that kind of stuff, which you're going to have to adjust. Start. Yeah, it's pretty good. Look at that. And if I go to the left, yeah, so again, simulator not taking into account the safe area at all. It's just going with the information that it has, right? Because the simulator doesn't show a safe area here at all. All right, so this is pretty good. What about if we have another device? Let's go back with that Pixel 2 And do we get a better, is it going to look better than what it looked like before, which is what I'm hoping. And if we have something better than what we had before, and at least as good as what we had, then that's good. So let's go back to that pixel 2 and then see what that looks like. What do we predict is going to happen? So predictability wise, it should look better. It should look better. Look at that. That should look much better than what it was before on smaller phones like this. Okay, so let's go back to this. Oops. There it is. And let's just make this slightly smaller. Right? This is the Pixel 2. And let's go to File, Build Settings, and then Build and Run. What do you think, guys? What are your thoughts, Michael or Russ? I know the guys that have been working with me on this.
I think it works.
I think it works pretty well for those two.
I think there's I think we've without going into a lot of exhaustion to try and figure things out. We also don't have an iPhone to try things out with here. I do. I just don't. I haven't ported this over onto my Mac, but I could for next time. So that's something we can check out, and I can post the results of that.
I've been following along. I've still been trying
What do
to
you
do
mean?
my own thing.
Didn't you accept our solution?
What do you mean? What do I mean? I'm trying to
Didn't
solve
you
it
accept the
myself.
solution to the problem? I'm joking. I'm joking.
I'm doing my own math.
I like your math.
Everything's coming out just like it's just off by a few pixels, and I can't figure out why.
Isn't that the beautiful thing about finding out the problem, right? So let's take a look. Okay, that's pretty good.
Might be that scale.
Look at
but I
that.
don't
That's
know
like
why
way
it
better
would
than
be.
what it was before. Okay, let's move on to the left now. And yeah, that looks nice. So actually the Google Pixel looks really good as predicted, right? So from a smaller screen perspective and a larger screen, it looks like we're pretty good, and the labels move where they're supposed to move. Again,
If you change the lives label width to 400 and the score to 650, it's a lot tighter
because
to
of
the
that extra
edges.
boundary area that we gave it, right? Yeah,
Yeah.
that's good.
It fits the rectangle box that we see in the editor preview. So we get that empty blank space.
So what you're saying is inside of the canvas area, you're looking at the lives label you said was how big? What'd you make the width?
So if you make it 400.
So if you make it 400 the width.
So you'll see like that.
So you'll see like that
Yeah.
the yellow box around it is a lot
Yeah.
tighter because that's
We don't
what
care
we're
about
doing.
moving it to the left anymore because we're going to move it where it has to go anyway, right? So same. We can actually put this in the middle. if we want.
It'll automatically make it a lot tighter.
And the score label you made what? Just curious.
Score I did 650.
Score I did 650.
Yeah.
You could do maybe
You could do
Even
maybe
more.
even
Yeah,
a
look at
little
that.
tighter.
You still have a little bit of leeway on both sides because we still got 10,000 we can hold in here, right? Let's look at 630. Yeah, 630 works. How about even smaller? 620. Yeah, 620. How about, do I hear 610? Yep. 610.
600 was too small for me.
610. All right, let's try doing it here like that and see what happens. Yeah, look at that. Way better. Way better. It's not quite at the edge. It's not quite at the edge, but it's way, way better than what it was. Yeah, and it's gonna be way tighter when we go into different orientation modes, right? That's great, Michael. Thank you. All right, so I'm going to post this solution. I think it's as far as I want to take it today. I'm not sure if you guys want to take it further, and if you do, if you can share it on Discord, that'd be great, or like your link to GitHub. But I'm going to put this up on GitHub for now. So let's move back to the Samsung Galaxy S10 Plus and just check it here for a second and see what that looks like. That's a little tight. It's a little tight. Maybe we want to add a little bit of stuff there. You know, look at that. It's a little bit huggy on the right and left, and that's why I added that extra space. So maybe lives label would be like 410, and the score label would be like 620. Even though it's not as tight, it might produce a little bit of padding or margin and even that's not too much. Even more. So maybe make this.
In the chat a while back, I sent you another possible solution I found online. They had an interesting approach to it.
I mean, I'm glad we found our own. To be honest,
Yeah.
I'm happy with that. Let's go 450.
Doing it ourselves.
Yeah,
is
well,
awesome.
it's just better for everybody, right? I think that I might go with 450 as a thing, because see, I get a little bit of margin on this side and on this side for the width, right? I might do that. I know it's not as tight as yours for the lives label, but probably 450 and 650 might be a better value. Anyways, I think I'm done as far as I'm going to go today, and we're going to continue stuff next week.
So, what did you do for the scaling? I think that might be the thing that's messing up my.
Sure.
Slightly, everything works. I'm just slightly off by
So
like
what
a
I
few
did,
pixels, and I'm
gonna
wondering if
clean
it's
up
the
this code
scale.
too.
That
So what I
I'm
did was I said this. I said, get the canvas scalar. When I got the canvas scalar, I created a new vector that took the current resolution from the screen and divided it by the height. So I got the new current resolution, because current resolution of the screen gives me a screen resolution object, which is not a vector. And then what I do is I took the scalar reference resolution that we gave it, right? And I took the current resolution divided by the scalar resolution, which gave us a ratio of widths and heights. And once I had that, then I multiplied those by the half widths and half heights, which gave me the right scale. It's closer. If that makes sense.
Yeah, I'm just copying it out. Yeah, I'm just copying it out.
App stop running. And I'm just gonna. Here, I'll post it for you if you want. Can we post it in the chat?
I don't have a reference. I don't have a reference. What's reference resolution? I don't see. Oh, never mind. Hang on.
I wonder
said it
if
as
for
the
the
thing.
screen resolution, if instead of the current resolution dot width, if we should do the safe area dot width, because the safe area might be a little bit
try it.
smaller than
You
the
should try
current
it out,
resolution.
because that's something that I'm just gonna kill all this extra stuff that we just did, because we have that. I already have another lab that we did, so this is like lab 2B. This is the like version 2B of the lab. But look how much tighter that is compared to checking for orientation changes and stuff, right? This part right here, these 2 lines of code did all that orientation change stuff, if you think about it. And going with what Russ and you were saying. So I got to give you guys credit. Daniel, I'm going to be right with you. So let's post this up, and I think this is a good, again, a good first solution. I think there's more we can do here, and more. I think we can even optimize more than this, to be honest. Like you said, Michael, there's probably places we can get for the safe area as opposed to the current screen resolution, because that'll give us. But what I do is I do take the safe area into account, though, right? Wouldn't we want to get the safe area, the current screen resolution for a ratio perspective? Because look, we are using the X-min and X-max and the Y-max of the safe area. That's how we're positioned.
Yeah, it's just for determining the scale, I think, because we're getting the current resolution. So let's say it's 1920 by 1080 is the current resolution. But if you have a notch, it might be 1850 by something.
Oh, the
instead.
resolution of
So it might just be
the safe area, the width and the height of the safe area is a ratio, as opposed to the screen.
Because
But I wonder if there's going to be an offset,
like,
then that would be an offset too. We'd have to worry about the. I don't know. I'm good here.
Yeah.
I'm not going to work.
Yeah,
I think I'm gonna stop myself. I think I'm good fairly good for what I've got. So let's save this thing. I'm going to close this down. Hopefully you guys got that. And I'm also going to close and save Unity. File, save project, save the scene, close this down. Let's put this up on GitHub. And then you'll have everything that I have. And that should be good for today. Way more than good.
All my stuff is still off. All my stuff is still off. It's driving me nuts. It's like so close.
We'll say refactored. Kind of a catch-all. There. So you're going to have that up on GitHub, guys. All right. Sorry. So Daniel, you had a question with your Genymotion. What did you have with Genymotion that was a problem? Can you want to share your screen? I'm gonna give you the ability to do that because that way you can show us what you got. Okay, I'm going to stop sharing my screen, and you can go ahead with yours. But a big thank you shout out goes out to Russ and to Michael for all the help you guys gave me when it comes to this. This is pretty awesome, guys. And you know what? I better stop recording before you put your stuff up there, because we are recording up on YouTube. So just give me 1 sec while I stop recording. So thanks, guys. And for the people who are watching live, we'll see you next week.